Today I am explaining the charged tapes Physics 2 lab. For this lab, we're going to use charged pieces of clear tape to observe the properties of charged objects. I will make deductions about the amount of charge on the tape and how the electrons move between different pieces of tape. To get results, I will use a combination of Python code and experimental measurements. These are the ideas you need to understand understand the logic behind this lab. These surroundings are the air, the table, the base tape, and my hands. The system are the two charged tapes. The tape is neutral before being charged, and the base tape is also neutral before being charged. Another important initial condition is that the hanging tape is still and the center of it is affected only by gravity. So an expectation I had is that two U-tapes repel each other because they have the same charge. And I observed this to be true, and also that U-tapes are attracted to neutral objects. So I used a negatively charged pen, and the U-tape was attracted to the pen. So I was able to conclude that the U-tape was positively charged because it was attracted to a negatively charged object, and they also repel each other. So for the floating tape portion of the experiment, since the momentum of tape B is not changing, the net Y components of the force must be 0, and the A tape is exerting vertical forces on the hanging portion of tape B. So here in this free body diagram that I drew, you can see that the absolute value of the electric force equals the absolute value of the gravitational force on the hanging tape, or tape B. And that is important for the formula we will use later. So we need to determine what the force of gravity is on this hanging tape, or tape B. So we are able to determine this with its length and knowing its mass is 1 gram per meter. And using the F equals mg formula, we found out that the force of gravity on tape B is 0.0022 newtons. So some assumptions we made are that both tapes have the same net charge evenly distributed along the length of the tape, and that for our calculations, we can treat each tape as if all its charge were located at a single point on the center of the tape. So the distance at which one piece of tape began to float above the other was 4.5 centimeters, and gravitational force and electric force is equal and is 0.0022 newtons. So we use these values and this formula as the basis of logic for our code. So the unknown in this formula is Q1 and Q2, but we know from our assumptions earlier that Q1 and Q2 are actually equal, so we only need to find one of them. And we are able to use algebra to move all of our knowns over to one side and just have the unknown, which is Q1, on one side, and just use algebra to get a value for the unknown. This is my code implementation, so my QSolve code does that algebra I was talking about earlier and returns the magnitude of the charge in coulombs on one piece of tape, and the magnitude result that we got is 2.22 e to the negative 8 coulombs is the charge on one piece of tape. So what are some sources of error? There was probably some humidity in the air, and I still did have to touch the tape. I tried to touch it only on the ends, but still I may have discharged it a little bit through touching it. So what if the electrons had a positive charge and the protons had a negative charge? The tape would still float because the tapes would still have an opposite charge. However, they would interact differently with the negatively charged pen, I think, because the instead of ripping off negatively charged electrons, we'd be ripping off positively charged electrons when we rip the tapes apart. And why is it important to handle the charged tapes as little as possible? Because we don't want to ground the charged tapes by touching them too much. The charge will kind of spread into our bodies and into the ground that our feet are on, and this is called grounding. So my conclusion is that the magnitude of the charge was 2.22 times 10 to the negative 8 coulombs. The tape is positively charged, and that like charges repel, opposite charges attract, and neutral objects are attracted to charged objects.